Okay, so my name is Sejong Yoon, and this is a collaborative work with my students, and then all these two students are basically undergrad students because we are the primary undergrad institution in New Jersey, and we would like to share our experience with the data set and applying on the deep neural net. So our network structure is pretty straightforward, and we are using the linear net stack of linear network. Although the figure is a bit messy, but it's really at maximum of 10 layers. And our motivation here is to reduce the dimensions of each feature so that all the features are kind of treated in balanced way. So as you already know, if some of the features have too many dimensions than compared to the others, then they are unfairly considered as important. So just to enlarge a little bit, then you can see the way we reduce the features. And all these hyperparameter decisions were based on our undergrad students' hard work of the many nights and days. And then really after the concatenation, there are several ways to fuse these features, but we simply simply use the concatenation because we really couldn't find a significant difference between the method. And then later on, after the concatenation, we added a slightly more, actually 3 more layers to further narrow down the dimensions and finally add the Euclidean laws to do the regression. So this was already shared in the overview session, so I'll skip it. And then this is our result on the depth set. And one of the issue of this training the big neural net, and actually the previous talk actually had the same issue, I believe, because we also observed a similar symptom as well. So that the cause is the neural net is losing the gradient in the middle because the network is so large. So in order to alleviate the issues, we kind of pre-trained the lower layers of the network. So in the previous slide, so you see that these yellow shaded areas, for each of the feature type, we pre-trained that part of the layer so that we can kind of overcome that issue. So here the model A is training everything from end to end, and model B is using the pre-trained part. So model B is still, model A and B are still, the network structure is the same, but model B has pre-trained the lower parts in advance. So they kind of, as you can see, they kind of have more balanced performance on the depth set and the test set. So, and also it means that with it actually is trained better. I mean, it trained in a right way, moving toward the better generalization performance. But we also found that the long-term memorability is significantly harder than the short-term one. And another issue is that we couldn't, because of the schedule issue, we couldn't include the caption feature that turns out to be pretty significant. And that is what's shown in the row C, okay, method C. So that's basically the caption feature. So that's it. And the summary, so we attempted a large deep neural network and combining multiple features. And we reconfirmed some of the facts that many of you have already presented. So the long-term memorability is harder than the short-term, and the high-level semantic information helps. And we also found that about 8.5% of the long-term memorability score is simply ones. And that means for that many videos, you can't really tell the difference between which one is more memorable than the other. And is it significant? Well, actually, mathematically, it's not significant because if you compute the correlation, Spearman's rank correlation with making the making some of the values at the same, and let's say 8.5%, then what you are losing is basically dropping your correlation score from the perfect to the 0.9997. So that means the performance-wise, it's not that much significant, but analysis-wise, that may say something. So maybe the more robust method is to deal with that kind of characteristics of a long-term annotation. There was one other interesting analysis was presented earlier in one of the earlier talks, the direction of the video flow. So that kind of a method that can deal with that kind of things would be something very interesting to pursue in the future. So that's all from me, and I would be happy to answer any questions.